In this video, I just want to introduce this idea of using Docker containers to run analysis in an environment where you have everything under control. So I just want to do a couple of quick examples on how this might be useful, and then I want to show you actually working version of running FSL under Linux actually on my Mac OS machine, which I got to work. So this might be helpful in some circumstances where you on a Windows machine or a Mac and you don't want to have to install a particular version of FSL that's sort of required to run a particular kind of code. So let me just show you what's going on here. So I'm in a folder called demo on my laptop. So if I type hostname, you can see that this is my MacBook Pro laptop. If I type uname -a, that gives you some information about what operating system we're running on. And you can see that we're on Darwin, so that's Mac OS, various bits of information about the operating system here, right? So I have local install of Python, Julia, various other tools here. But let's say I want to actually run in an environment in which I have control over what it is, and this might be, say, a Linux environment. If you have Docker installed, so you can see up here in the dock of in the menu bar of my Mac, there's this system icon. So I've got Docker Desktop installed. So this is now running on a Mac, but obviously on a Windows machine, Docker Desktop exists as well. So you should be able to reproduce similar things on a Windows machine. There's a command line tool that gets installed when you do this, which runs Docker. So it's a whole bunch of help that goes along with this. One thing I can do is, for example, look at which images of things have been installed. So there's a listing of all the Docker images that have been created on my machine. It's not really important what all these are at the moment. But this shows you the images that have been built on this machine or downloaded from a repository somewhere that we can run if we want to do this. So just to give you a quick example, this is a programming language called Julia, which I quite like using for certain kinds of tasks. If we want to run Julia on this machine, I could run my local copy, but we can run the one in the container actually, which is built for Linux and has all the dependency that it needs to run whatever it does on this machine within a Docker container, so-called container, okay? So in order to do that, we type docker run, and we give it a couple of options here, which I can tell you in a little bit more detail in another video at some point. We want to remove the container once we've stopped it, so that means we don't actually start filling up our computer with these containers that keep on running in the background. -IT means I want to run it interactively. And there's a container called Julia, actually, which has been tagged with the name Julia, and I can run this now. And now you can see I'm running version 1.5 of this interpreter for this language called Julia. But am I actually running on my local machine? Well, we can look at what the host name is of the machine that I'm looking at, and you can now see it's got this weird little SHA information. If I type uname -a, it will tell me what operating system this container is actually running in, and if it was local, then it would be Darwin, Mac OS, but you can see it's actually Linux. Okay, so it's running actually in a Linux environment, and if I list all of the the contents of the system files that are available here, you can see it actually looks like a Linux environment, not like a sort of the Mac version here. Okay, just to let you know how I'm dropping into the shell environment. If you press semicolon here, then that switches to the shell. So sort of a neatness of Julia. So Julia does stuff like you can do calculations and write code. It's very nice. So if I exit this, then I'm back in my local environment. Okay. So you might not be interested in Julia, but similar things exist for Python, for example, right? So I can docker run. I'll do the same trick, -rm -it -rm -it, and let's say I want to run Python, but with a particular version. So these Python text here is a tag that's attached to a particular image that we can run. Say for example 3.5, and I want to run it on the background of Debian Stretch, which is sort of a code name for one of the operating systems. And let's see what happens when I do that. Okay, so in this case, I haven't actually got this version of the operating system installed. So Docker will go away to a repository, download the necessary layers to build this particular container, and then it will drop into a Python interpreter, which now runs in version 3.5, as you can see, 3.59, that's the version of Python, and it's running on a Linux background operating system. Okay, so you can see how this is actually really useful. So the first time you run a new kind of container where you don't have the layers on your local machine, it actually needs to do this download. But if I exit from here, so I'm back here, you can now see if I do docker image ls, you see that we now have different versions of this Python image present. They're not actually that huge, it's a little bit less than a gigabyte. So if I wanna run this image again, it drops me straight into it now. It doesn't reload it. So it's very clever about caching things. Okay. So you can see how this might be quite useful for having a particular version of an operating system that you can access on your local machine, whether it's Mac OS or Linux, with particular libraries and so on. Okay. And so this is just a very simple version in which we are dropping straight into a particular interpreter or tool, but you can build many more complicated sort of environments, including ones where you can pip install files and conda install various things for Python and so on. And one thing you can do is, for example, have a particular version of FSL installed on your machine, which you can then run even though you are, say, you want to run the Linux version of FSL of a particular version, say 5.0, but you don't want to have to install something else on your machine. You can just run it through one of those Docker containers. Okay, and so I've actually looked in this at this here. So in order to test FSL on my machine here. So one of the things we want to do is we want to be able to maybe interact with some GUI elements here, and this makes running this container a little bit more complicated. So if you concentrate on this code that I've highlighted here, you can see that this I issued this command called docker run. Actually, I guess I could put rm --rm and -it right at the top here, so it's more similar to what we've seen before. We can tag the container that's running with a particular name, although Docker will will make up a name, so we can actually look for it. In this line here, I'm actually making a drive on my local machine available inside the container. So if you want to share data between this isolated container and your local machine, you need to jump through some hoops. So I'll show you how that's done in one of the things here. And then I found in a blog post, which is down here, how to forward X11 GUI windows from inside this container that's running on our machine, so we can actually look at things here. So on my Mac, I had to start Xquartz, which is sort of X11 client for running GUI Unix programs. And the other thing that's different about this command to what we've done before is I'm actually running a particular image that I have built, which has a much more complicated Docker file associated with it, which I will upload on a GitHub repository. Okay? And so we run this particular image and create a container with it and drop into Bash. So we have actually got access to an interactive window, so we can interact with the container through the terminal. So just to show you, so if I do docker image ls, you can see there is this file here, test mypipe_eh for initials of one of my PhD students. And it was built just a couple of minutes ago. It's a particular ID associated with it. It's sort of about 4 gigs big because it has an FSL install and various other things in it. And so what I'm going to do is I'm going to copy and paste this command over here into the window and see what happens. Okay, oops. I'll say, so there's a container already running. So let me just, let's say this might happen to you. So let me just go to the dashboard here. So this is the container before was sort of, we could reconnect to this guy, but actually I'm just going to close it down here. So I'm going to stop it. Stop the container. And then delete it. Okay, so there's no containers running. So let me just try that again. Clean the window here. Run this. Okay, and you can see I now have this sort of slightly odd looking command prompt. We can do this trick of finding out where we're actually running. So this is a machine that's got this particular name here. What operating system are we actually running? Is it Mac OS? Oh no, it's Linux. And you can also look at the folder contents, which you don't have to worry about here. Slash contains the sort of the root of the file system here, and you can see it looks like a standard Linux kind of thing. And if I launch FSL now in the background, the window stuff that would usually run on this Linux machine gets forwarded to my Xquartz. Okay, so we can actually run the interact with the GUI here as well, and so it looks like this might actually work. Puts these things up. So this is running on my OS 10 machine, but communicating with what's happening inside the container. Now I've set this thing up such that we actually have a folder called home data, and there's a bunch of files in here, which you can see. And so this folder called home data is actually pointing at a location on my local hard drive. So when I modify files on my operating system here, so if I go to that folder, I actually have it in a demo folder called test data. You can see that there's 3 data files here and this Python analysis file, which let's remove that. So I'm going to trash that here on my local machine. And if I look back here now, it's this, in this home data file, it's disappeared. Okay, so it was here before, but it's not there anymore. So this is a nice way of interacting, basically putting data inside the container. Or conversely, if you're doing some processing and you need to store the information and sort of hold on to it and not destroy it when your container finishes, this is the way to achieve it. It's one of the ways to achieve it. Right, I'll stop this recording here now, and in one of the next ones I'll go into a little bit more detail on how to set up these mounts of the drives and deal with some of the environment variables.